Okay, let's talk about number 8. We have a 15-inch by 22-inch sheet of aluminum. We are cutting a square out of each corner and then folding it along these dotted lines to make a box that will look a lot like this. The first thing we want to do is find the domain of this situation. This is what we've done in class. We took an 8.5 by 11 sheet of paper. We cut a 1-inch square out of each corner and made a box. And we calculated the volume and surface area. We did a 2-inch square and we calculated the volume and surface area. We did a 3-inch square and calculated the volume and surface area. We did not do a 4-inch square, but if we did, this would be the volume and surface area. Well, what about a 5-inch square? That would be okay vertically, but what about horizontally? The two squares would overlap and it would be impossible to make these cuts. About the biggest cut we could make would be 4.2 if we rounded to the nearest tenth. Again, this is an 8.5 by 11-inch sheet of paper. The biggest cut we can make is just a little bit less than half of 8.5. And 8.5 divided by 2 is 4.25. So our domain of the sheet of paper was 0 to 4.25 with parentheses, not brackets. So the domain here is 0 to 1/2 of the smallest dimension, 7.5. The volume of the box is equal to the length times the width times the height. The height of the box will be the length of the cut, x. And since it's the monomial, let's put it first. This length right here is 22 minus x, or 22 minus 2x. Likewise, this length is 15 minus x, or 15 minus 2x. Let's use our TI-84 to find the maximum volume. Okay, we have our TI-84. I am just starting with the standard viewing window. Let's input the function and hit graph. All right, we don't see a whole lot. The function is going to look something like this. So we need to take our Y maximum way up. I'm going to take it to 250 and scale it by 50. That's not bad, but we need to go higher. So instead of 250, I'm going to go to 350. Again, not bad, but I need to go a little higher. Let's make it 500. Okay, that's high enough. We need the coordinates of the peak. So the keys that we hit are second, calculate, option 4. The calculator is asking us a question. What is the left bound? I'm going to take it a little bit closer to the peak, but left of the peak, and hit enter. The calculator is asking us a question. Is this the right bound? Right now the answer is no, but we take it to the right of the peak. The answer is yes, so let's hit enter. The calculator is asking us another question. Do you want me to guess? The answer to that is yes, so let's hit enter. We get two values. X is the length of the cut at maximum volume, and Y is the maximum volume. Now let's talk about the surface area. We could do the surface area by finding the area of this rectangle and adding the area of this rectangle. This one would be the same area as the one over here. The area of the bottom would be the same as the area of the one on the top. And then we could find the area of the bottom of the box. That's kind of the hard way. The easy way is to understand the area of the original sheet of aluminum is just 22 by 15. We then cut an x by x square out of each corner. So in other words, we subtract 4 x by x squares. Well, the calculator already understands what x is, so what we have to do is 22 times 15 minus 4x squared. That gives us this result. Now for part E, we need to find the cost of the material. We are using 295.847 square inches of aluminum, and we just multiply that by how much 1 square inch costs. Now keep in mind, this is money, and you should round that to 2 decimal places instead of 3, but I will code it both ways. I hope this video helped. See if you can do number 9.